the math section of the ACT getting you down? Does this feel a little overwhelming, especially with the timing? Do you ever get stuck on questions and you just can't move on? Have no fear. Today, we are going to talk about the top 5 biggest mistakes I've seen my students make on the ACT math section and how to prevent them in the future. Hey guys, and welcome back to my channel. If you're new here, my name is Megan. I am your test prep guru and expert of all things ACT, SAT, and college admissions related. Today we're going to continue a series on the top mistakes that I've seen my students make over the last decade that I have spent tutoring. Last time we did the ACT English section, and today we're going to tackle the math section. If you missed my English section video, make sure to take a look in the description below because I will have a link for it there. Also, if you're studying for the SAT, make sure to stick around because a lot of the mistakes we're going to be talking about with the ACT can apply to the questions on the SAT as well. Let's get started. Mistake number 1, using your calculator inefficiently. So one of the little known secrets of the ACT math section is that you actually don't need a calculator in order to get through all of the questions in the time that is required. A calculator is just a helpful tool in order to get you through it a little bit faster. The problem is that people tend to over-rely on their calculator. They reach for it as soon as they get any question with numbers, which is literally every single question on the ACT math section. Instead of that, you want to make sure that you're checking what the question is asking first, because sometimes there's an easier way of getting to the correct answer, and a lot of times it's going to be a lot faster as well. Let's take a look at an example of how multiplying fractions can be solved within 15 seconds.
This is a product of fractions. We have 1/4 times 2/5 times 3/6 times 4/7 times 5/8 times 6/9 times 7 over n. Now there's a couple ways that you can do this. Right off the bat, there are a couple of fractions where we can simplify them within the fraction themselves. 3/6 simplifies down to 1/2. Likewise, 6/9 can simplify down to 2/3. However, we can actually get through this process a lot faster just by looking at the numbers that are in the numerators and the numbers in the denominators and comparing them. So let's actually delete that. The great thing about fractions is that when you multiply them, you can actually cross-cancel. So this means that when you have a number in the numerator that has a common factor with the number in the denominator, then you can just cancel them out. And it works no matter where these numbers are in the fractions. So given this problem here, since we have 1 through 7 in the numerator, and then we have 4 through 9 and n in the denominators, then we can just go through and just cancel all of those out. So the 4s cancel out together, the 5s cancel out together, the 6s cancel out, the 7s cancel out, and then we're left with 1 times 2 times 3 in the numerator, and then 8 times 9 times n in the denominator. And we can cross-cancel even further. We can take out a 2 from the 8 and the 2, and then we can take out a 3 from the 3 and the 9 and change that to 1 and 3. And then we can go ahead and finish out our multiplication. All 1's in the numerator, so then the product will just be 1, and then 4 times 3 times n will give us 12n in the denominator, and that's going to give us h. When you get really, really good at questions like these and you can recognize them, then it can save you a ton of time on the test. So I actually see a lot of students take about 45 seconds to a minute in order to complete this problem because I feel like a lot of their basic instincts is to immediately reach for their calculator and then do that 1 times 2 times 3 times 4 times 5 times 6 times 7, and then 4 times 5 times 6 times 7 times 8 times 9 times n, and then try to simplify from there. And it's so much faster just by crossing off all those common factors and then simplifying as you go across.
So moral of the story here is to think about the problem before you just immediately jump into working it out. One of my favorite exercises to do to practice this is to try working through an entire math section without your calculator at all. That way, if you get to a question that is taking you 3 to 5 minutes in order to work through it, you can be pretty confident that there's a more efficient way of working through it and not necessarily the official math way. If you ever come across any of these questions, make sure that you drop a note in the comments below or bring it to a teacher, check the solutions in the back of that test, or just Google the question online and you'll get a whole list of different solutions from other people who have taken the test as well. Mistake number 2, jumping straight into working through a problem instead of thinking about it for half a second. So we already talked about this a little bit with reaching for your calculator as soon as you get any question with a number in it, but it also applies to questions where you don't necessarily need a calculator to solve the problem. Remember that this is a multiple choice test, so the answer is given to you, it's just mixed in with a bunch of incorrect answer choices. And this can be incredibly helpful in a lot of situations. Let's look at a least common multiple question in order to show this.
This is a least common multiple question as it's being given to you in the problem. What is the least common multiple of 70, 60, and 50? When we're solving for least common multiple questions in school, typically we will write out all of the multiples for the numbers that we're trying to compare. So for example, we would write out that 70 has multiples of 70, 140, 210, so on and so forth. And then we would do 60 is 60, 120, 180, and so on and so forth. And then 50 is going to give us 50, 100, 150, so on and so forth. Now, as you go through just the first couple of multiples, you'll start to recognize that you actually have to go pretty far in order to find the common multiple for 70, 60, and 50. So this is not a very efficient way of working through this problem. Instead, use the answer choices as a way to get to the correct answer. Instead of finding the first few multiples of each of those given numbers, we can just start by looking at the answer choices to see which one has the least common multiple. So I always start with the smallest number because they're looking for the least common multiple, so you want to start with the smallest number. If you start with a number in the middle or at the higher end, even if it is a common multiple of the 3 numbers that are given to you, that doesn't necessarily mean that it's the least common multiple, and they are putting the emphasis on least. So then I would look through. So F, 60. Well, 60 does not have a factor of 70 or 50, so we can cross that one off. 180 does not have a factor of 50. 210 does not have a factor of 50. 2100, right off the bat, we know that it's divisible by 50 because it ends in 2 zeros, so that works. We also know that it's divisible by 70 because it's 2100, which 70 will go into, you just cancel out the zeros, 7 goes into 21 3 times, and then you just bring over the 0, so that works as well. The last one is 60. This one also works because for 2100, you just divide it by 60, again, cancel out the zeros, and then you just have to check to see if 210 is divisible by 6. Now, you could actually work that out. You could reach for your calculator, or you can use your good old-fashioned divisibility rules. In order to be divisible by 6, that means that it has to be even, and then it also has to have the sum of the digits has to be divisible by 3. And this checks both boxes. 210 is even, and also if you add up 2 plus 1 plus 0, you get 3, so it's divisible by 3. So then I know that J is going to be the correct answer. And what's great is that I don't even have to check for K because even if it is a common multiple, again, it's not the least common multiple. Also, I know that it took me a little bit of time in order to work through this problem. On the actual test, especially if you know your divisibility rules, this will go through a lot faster because you'll be able to just cross things off right away. Last point 2, little number sense problem, is that all of the answer choices and all 3 numbers that you're trying to find multiples of all end in 0. So right off the bat, you can cancel out all of the zeros, and you can actually think of these answer choices as 6, 18, 21, 210, and then 21,000. And then you can think of these as 6, 7, and 5 instead of actually working through them with all of those zeros.
So the moral of the story here is to think about the problem before you just jump straight through. Try labeling the question. If you know that it's a fractions question, then you can start checking to see if you can cancel out common factors from the numerators and the denominators. If it's a least common multiple, like we just saw, jump immediately to the answer choices. If it's a pie chart, then you can start figuring out if you need to add or subtract the different percentages before you start finding out how much each of those percentages are worth. Point is that you have to think about the problem first. And again, the exercise is very similar to the calculator mistake, which is try working out a lot of questions without a calculator, and then also periodically time yourself. If it's taking 2 minutes, then you can probably find a different way, a more efficient way of solving that problem. Mistake number 3, ending the question too quickly. Majority of the questions on the test are going to be multiple step questions, meaning that it's not just a one and done. You don't just do one step, one calculation, and then you can find the correct answer and you're good to go. A lot of times you have to work through the problem in multiple layers. The problem with this is that the test makers are very smart, and they know that all the different answers that you get along the way are going to be great trap answers that they can include in the answer choices. So let's take a look at a question where this came up on a recent test. Here we're going to look at number 2 to show how the different numbers that you get as you're working through a problem will also show up in the answer choices. And what's great about number 2 is that there are a couple of traps along the way. If r equals 9, b equals 5, and g equals -6, what does, parentheses, r plus b minus g times, other parentheses, b plus g equal? This is a basic substitution question. So you take the values of each of the variables, plug it into the expression, and then simplify. So since r is 9, we're going to do 9 plus, and then b is 5, minus, and then we have to put in -6 for g, close our parentheses, and then b5 plus -6 again. So 9 plus 5 is 14, and then a minus a negative is the same thing as adding a positive. A little trick that I learned when I was doing this first is that you just make this into a big, huge plus sign. So then we're going to make this 14 plus 6. So our first set of parentheses is going to equal 20. And now we can look at the second set of parentheses. 5 plus -6 is just -1. So then we're going to end up doing 20 times -1, which will give us a final answer of -20. So our answer is going to be F. Now, couple of things. First and foremost, notice that the 20 shows up here and in the answer choices. So if you were working through this and you just got through the first set of parentheses and you completely ignored the second set of parentheses, or you just got caught up in the test because it's the ACT and you're trying to do your best and work hard on this test, you could easily miss that. See that you get the answer 20. It's one of the answer choices, so you could circle it and get the question wrong. So you have to be aware of these. The other thing to notice is that there's a couple of traps here too. First and foremost, let's erase this. So if you notice that the very first part, when we wrote 9 plus 5 minus -6. Now let's say that instead of doing minus -6, I just did -6. And then over here, I did 5 minus 6 because plus -6. And then I did this 9 plus 5 is 14. 14 minus 6 is going to be 8. And then we do 5 minus 6 is -1. And then that would give you -8. Now, obviously, this is the wrong answer, but notice that both this 8 here and this -8 here are trap answers for G and h. Likewise, again, I'm going to erase. If you went back to our original expression, we ended up with 20 times -1. Now, if you mistakenly added these together instead of multiplying them, that would give you 19. So all of the answer choices here are easily explained by different numbers that you could get through the problem, which is why it is so important to check yourself as you're working through the problem. Little side note as well is that when you're going through the test without a calculator or just practicing and not timing yourself, it's really helpful to take a look at the answer choices that are included just to see what are the test makers thinking. How did they get these answer choices? Majority of the times, it's because they know the common mistakes the students make and they include those answer choices like they did here as traps. So the better off you are at understanding how the test makers' minds work, then the better prepared you will be on test day to not fall for these traps. So the moral of the story here is to not end the question too quickly. Now this can be a little bit harder, especially because when you get an answer that's included in the answer choices, you think that you're getting the right answer. So there are two ways that you can check yourself. Number one is to label every single number or value that you get as you're working through the problem. You don't actually have to write this all out. You can make a mental note of it, but you do have to make a conscious effort of what that number means as you're working through the problem. That way, if you get the number 4 halfway through the problem and number 4 isn't one of the answer choices, you know that it's not the final answer because you've already given it a label. Number 2 is to double check the question. It seems tedious and it seems like it's going to take up a lot more time, but I promise you it won't. Especially if you get in the habit of underlining what they're asking for the first time that you work through the question, then it's a lot easier to just take a quick back look up, make sure that you're answering the question being asked, and then you can circle the correct answer. This is also really helpful if you have a couple minutes at the end of the math section. It's best to use that time by double checking, did you actually answer the question being asked, or did you circle one of the questions a little bit too early? Mistake number 4, not knowing the formulas that will come up on the test. So the ACT, unlike the SAT, does not give you a math reference sheet. However, there are going to be a lot of formulas that you need to know on the test that they're not going to give you, including slope-intercept form, the slope formula, the distance formula, the midpoint formula, the quadratic formula. You need to know how to factor, how to FOIL. You need to know triangle formulas. You need to know square and rectangle and other polygon formulas. You need to know your circle formulas. These are not going to be given to you on the test, so you need to make sure that you have them memorized or you have them put into your calculator as different programs. I will have 2 links in the description in order to help you. The first will be a link to my math cheat sheet. This will cover everything that you need for the ACT, as well as a little bit extra just to be on the safe side. The second one will be a step-by-step guide on how to program your calculator with these formulas. Remember that on the ACT, you are allowed to have programs as long as they don't take up more than 20 lines of code, which is a ton of room to work with, given the fact that these are pretty simple formulas and pretty simple programs that you're entering in. So make sure that you get those, set aside some time in order to enter those into your calculator so you have them ready to go if you don't already. Mistake number 5, not knowing the common patterns that show up on the test. Remember when I talked in rule number 1 that you don't need a calculator in order to get through all the questions on the ACT in the time that's given to you? One of the ways that the ACT test makers make sure that you can achieve this is by using common number patterns over and over and over again on the test. And these patterns range from simple ones like addition, subtraction, multiplication, division problems, all the way up through and including difference of squares, difference of cubes, how to FOIL, how to factor, Pythagorean triples, 30, 60, 90 triangles, 45, 45, 90 triangles, and basic fraction percent decimal conversions. Knowing these patterns can help you immensely, especially if you are struggling with timing on your test. So for example, a 3, 4, 5 triangle will show up in multiple different ways. So if you can recognize that a 12, 16, 20 triangle is actually a 3, 4, 5 triangle in disguise, then you don't actually need to use the Pythagorean theorem and deal with all those big numbers in order to solve that question. Instead, you can just say, well, the 12 is 3 times 4, the 16 is 4 times 4, and the 20 is 5 times 4. And so there's your 3, 4, 5 triangle. You can just plug in the values, and then you can simplify, solve for whatever you need to solve for. So let's see this in a triangle question. In the right triangle ACE below, BD is parallel to AE, and BD is perpendicular to EC at D. The length of AC is 20 feet, and the length of BD is 3 feet, and the length of CD is 4 feet. What is the length in feet of AE? First thing is that there is a lot of information that's in that problem, so I want to make sure that if it's not already in the figure that I add it there, so I have all the information in one place, not spread out between the words and the diagram. So first off, it's saying that BD is parallel to AE. So I'm going to just very small write the little parallel sign. Then they say that BD is perpendicular to EC at D. Now they already have the little box there that shows that it's a 90-degree angle, so we don't need to add that. Now we're told that AC is 20 feet, which is included. The length of BD is 3 feet, which is also included right here. And then the length of CD is 4, which is right here. So then they're asking for this length AE. Okay, so given all of this information, I know that this is going to be a similar triangles question because we know that triangle BDC is going to be similar with AEC. And that's because they both have a 90-degree angle here and here, and then they both share the angle at C, and so therefore this angle in here has to be congruent with this angle in here. And so if they have all angles congruent, therefore it's a similar set of triangles. So to solve this, we use proportions. Now, right now we have the bottom leg of the smaller triangle, but we don't have this whole entire distance from E to C. We do have BD, but we don't have AE. And we do have AC, but we don't have BC. Now, we could use the Pythagorean theorem for this little triangle inside that has 3, 4, and then x. So we could go through the whole process of a squared plus b squared equals c squared. However, that can take a while, especially because the 3 and 4 legs of this right triangle tell us that it is a Pythagorean triple. So the Pythagorean triple is the 3, 4, 5. This is the common ratio for a Pythagorean theorem. It is the smallest common ratio for the Pythagorean theorem, and so we automatically know that x is going to equal 5 here. And what's great about this is that we also know that AEC is going to have that same common ratio of 3 to 4 to 5. So then we just need to figure out to go from this small hypotenuse here, BC, which is 5, to this big hypotenuse, 20, we have to multiply by 4. So that means that each of the sides of this small triangle are just going to be multiplied by 4. So to go from 3 to AE, we just have to multiply by 4 as well. And so our answer is going to be 12. So the moral of the story here is to know your common patterns. I will have these patterns included in my math cheat sheet, which again is going to be linked in the description below. So there you have the top 5 mistakes that I've seen my students make over the last decade. Hopefully they will help you prevent making these mistakes in the future. If you liked this video and found it helpful, please give it a like and subscribe to my channel in order to catch videos that I post in the future. Also, if you have any questions on this topic or anything about the ACT, SAT, or college admissions process, please let me know in the comments below, as well as letting me know of any specific topics that you would like me to cover. Thanks for watching, and I'll see you next time.